In this problem, we are given a quadratic function f of x equals x squared plus 2ax plus 3, and told that it is monotonic on the interval from negative infinity to 0. Our goal is to find all possible values of the parameter a that make this true. A monotonic function on an interval means it is either entirely non-increasing or entirely non-decreasing. But for a quadratic opening upwards, we need to analyze its vertex position relative to the interval. First, let's restate the problem clearly. The function is f of x equals x squared plus 2ax plus 3. This is a quadratic function, and since the coefficient of x squared is 1, which is positive, the parabola opens upwards. This is important because it determines the shape of the graph. It has a minimum point at the vertex, and the function decreases to the left of the vertex and increases to the right. Next, we find the vertex of the parabola. For a quadratic in standard form, ax squared plus bx plus c. The x-coordinate of the vertex is negative b over 2a. Here, a is 1 and b is 2a. So the vertex is at x equals negative 2a over 2 times 1, which simplifies to negative a. So the vertex is at x equals negative a. Since the parabola opens upwards, the function is decreasing on the interval from negative infinity to negative a, and increasing on the interval from negative a to infinity. Now, we apply this to the given interval from negative infinity to 0. For the function to be monotonic on this entire interval, it must be either always decreasing or always increasing. However, because the parabola opens upwards, as x approaches negative infinity, f of x goes to positive infinity. If the function were increasing on negative infinity to 0, then as x increases, f should increase, but starting from infinity at negative infinity, it would have to decrease to some finite value at 0, which is impossible. Therefore, the only possibility is that the function is decreasing on negative infinity to 0. This means that the entire interval must lie to the left of the vertex, where the function is decreasing. So the vertex at x equals negative must be to the right of or equal to 0, i.e., negative a is greater than or equal to 0. From the inequality negative a greater than or equal to 0, we can solve for a. Multiply both sides by negative 1, but remember that multiplying by a negative reverses the inequality sign. Actually, negative a greater than or equal to 0 implies that a is less than or equal to 0. So, a must be in the range from negative infinity to 0, inclusive of 0. Therefore, the range of a is all real numbers a such that a is less than or equal to 0. To recap, the correct answer is option D, a in the limit stem, negative 0. This range ensures that the vertex of the parabola is at or to the right of 0, making the function decreasing on the interval megas 0. Let's briefly check why other options are incorrect. Option A and B have a less than or equal negative 1, which is too restrictive. For example, a equals minus 0.5 works, but is not in negus, negative 1. Option C has a between negative 1 and 0, but a equals negative 2 works and is not in that range. So only D covers all valid values.